Good day. Today we're going to be looking at dividing radicals. Step 1 for dividing radicals is to divide the coefficients and then use your quotient rule. Simplify the resulting radical. So for number 1, if I have 12 divided by 2, this is going to give me 6. If I do, it's 6 times 160 over 5. 160 divided by 5 is 32. I said 32 and root 36. 32. If you want to use Desmos, you can, or you can do this by hand. This is 6 times the square root of 16 times the square root of 2. 6 times 4 times square root 2, which is 24 square root 2 as our final answer. Let's do number 4. 28 divided by 4 gives me 7. And I'm left with the cubic root of negative 16m to the 6th divided by 2m. This is negative 8. And m, 6 minus 1 is 5, so m to the 5th. All right. From here, I have 7 times the cubic root of negative 8 times the cubic root of m to the 5th. 7 times negative 2. 3 goes into 5 once, so m to the 1st. And I have 2 left over, m squared. Negative 14 m cubic root of m squared is my final answer. Number 6. The cubic root of 40 over 27. I cannot pull out any factors between 40 and 27, so this is going to be the cubic root of 40 over the cubic root of 27. The cubic root of 40 is 8 times 5, so cubic root of 8. Cubic root of 27 is 3. This is 2/3 cubic root of 5 as my final answer. Let's do number 8, and I'll let you do the other 4 problems. Number 8 is quartic root of 32w divided by 81. So I'm going to do the 4th root of 16 times 4th root of 2, so I broke apart 32, times the 4th root of w over the 4th root of 81. The 4th root of 16 is 2. I don't have anything I can do with the 4th root of 2. I'm going to leave it. And I'm going to leave the 4th root of w. The quartic root of 81 is 3. So I have 2 4th root of 2w over 3 as my final answer. Pause the video and try those remaining 4 problems. Now let's talk about rationalizing the denominator. If you have a monomial, so one term in the denominator, you're going to multiply the top and bottom by the denominator's radical. If you have a binomial denominator, you have to multiply by the conjugate. This makes it a different of perfect squares, so it simplifies the bottom easily. You'll see that here in a minute. But let's get started. Number 10, 8 over 15. I can't do anything with this, so I'm going to put the square root of 8 over the square root of 15. I'm going to multiply top and bottom by the square root of 15. 8 times 15 is 120. Or if you want to break this down really quickly, instead of doing 8 times 15, you can break it into prime factors. So I'm going to write this in red. 8 is 2 times 2 times 2. 15 is 3 times 5. That just will make your problem easier. The square root of 15 times the square root of 15. Either you can write that twice, or you can put the square root of 15 squared. Or I suppose you could have put 225. Either way, you're all going to get the same answer. The square root of 120. This has a perfect square of 4 times 30 divided by square root of 15 square root is 15. So 2 square root 30 over 15 is my final answer. If you would have done it the red way, you would just mark out a 2, took 1 to the outside, 2 square root 2 times 3 is 6, times 5 is 30, and had over 15. Either way gets you the same answer. I just wanted to show you. Let's look at number 12. 28 a to the 5th divided by 3a. Now, I cannot simplify the square root of 3a, and I can't do 28 divided by 3, but what I can do to make this problem easier is to go ahead and separate out some perfect squares. So, this is the square root of 28a to the 4th, it's 5 minus 1, over the square root of 3. The square root of 28 has 4 times 7. So 2 square root 7. Should have left a little bit of a space there. And the square root of a to the 4th is a squared. All over square root 3. Multiply by the square root of 3 on top and bottom. I have 2a squared, square root of 21, divided by 3, and I am finished. All right, let's do number 14. 3 square root 2 plus square root 6 divided by square root of 12 is square root of 4 times square root of 3, so 2 square root 3. I'm going to multiply on top and bottom by the square root of 3. Don't forget, I have to distribute to both terms. So this is 3 square root of 2 times 3 plus square root of 6 times 3 over 2 times square root of 3 squared, which is just 3. This is 3 square root 6 plus square root of 18 over 2 times 3. 3 square root of 6 plus square root of 18 is 9 times 2, so 9 square root 2 over 6. The GCF of my numerator is 3, so I have 3 square root 6 plus 3 square root 2 over 6. This is equal to the square root of 6 plus 3 square root 2 all over 2. Finished. Okay. Man, I wrote this wrong. I knew something looked wrong, just didn't know what it was. This is why you should check your work. The square root of 18 is 9 times 2, but the square root of 9 is 3. So there should be 3 square root 2. GCF is still 3, square root 6, plus square root 2 over 6. So this should just be square root 6 plus square root 2 over 3, 2. Okay, if you want to check your work, I caught that just by looking and knowing something was off, but you can use Desmos to check it for you. Here's how. If I type in the initial equation, 3 square root 2 plus square root 6 all divided by square root 12, I get 1.93, and then it keeps going. If I type in my answer, square root 6 plus square root 2, all divided by 2, I get the same number. It is correct. Okay. I'm going to do number 15, 18, and 20, and let you try the rest. 15, the denominator is 4 plus square root 2. I need to multiply by the conjugate 4 minus square root 2. Now you can FOIL this if you want, but the reason why we do this is to make a difference of squares, such that I have 4 times 4 minus square root 2 on the numerator, and my denominator is the first one squared minus the second one squared. This gets rid of the radical. So this is 16 minus 4 square root 2 over 16 minus 4, 2. 2 squared is 4, square root of 4 is 2. My GCF is 4 on the numerator. I'm left with 4 minus square root 2 over 14. I can simplify this down into 2 times 4 minus square root 2 over 7. Final answer, finished. Number 18. I have square root 5 plus square root 3, so I'm going to do square root 5 minus square root 3 on top and bottom. So my numerator for FOILing, square root 5 minus 5 square root 3 minus square root of 5 times 5 is 25 plus square root 5 times 3 is 15. Square root 5 squared minus square root 3 squared. 5 square root 5 minus 5 square root 3 minus 5 plus square root 15. So this is 5 minus 3 on the bottom, so 2. And that is finished. I cannot simplify this any further. Okay. Let's look at number 20. My bottom is 3 minus 4 square root 6, so I'm going to multiply by 3 plus 4 square root 6. Eight times 3 is 24. 8 times 4 is plus 32 square root 6. Square root 6 times 3 is negative 3 square root 6 minus 4 square root 6 squared. 3 squared minus 4 square root 6 squared. So we have 24 plus 29 square root 6 minus 4 times 6 over 9 minus 16 times 6. For the numerator, this is 24 minus 24. Those cancel. I'm left with 29 square root 6. This is 9 minus 96, so negative 87. Just to make it look right, we're going to put the negative out front. 29 square root 6 over 87, and we're finished. This is it for today. So if you haven't already, pause it to try those. Try 9 through 13, and then 16 through 19. Now here are your answers. This is all that I have for you today, and I hope you have a great rest of your day.